This is my 6-year-old son, and when we have Nerf wars, he's gotten pretty bold and confident, but he doesn't know I'm about to put him in his place. This is a popular design called the Gryphon, a 3D printed, fully automatic, 150 feet per second plus Nerf style blaster, and both my kids have no idea what is coming. 150 FPS is too fast for kids, so we even added a PWM to slow things down to a friendly level, although it still ended in tears. I ordered the kit from Frontline Foam that included all the electronics except a battery, and even provided the project files so I could begin printing while it was being shipped to my door. We're going to print, assemble, add a speed controller, and remind my kids that I can always step up my game. The Gryphon comes in different difficulty levels, from one set of motors and no solenoid, all the way up to fully automatic with 2 sets of flywheels for 200 plus feet per second. We're building the fully automatic version with a solenoid, but only 1 set of flywheels to keep it more safe for the kids. There are 2 documents, and if you have a solenoid, you should start with that document like we are here. As you've seen so far, we're cutting wires to defined lengths, soldering them onto this XT60 connector. The included wiring diagram is helpful, but was a bit frustrating at first, so let me make it a little easier by adding more color to define what goes where. Also, at these points here, I ended up stripping the wire away so it could be soldered to the switch instead of what used to look like just passing by. Each switch has a purpose too. The switch above the trigger spools up the flywheels and will not fire the solenoid unless power is running to those motors. The trigger switch will engage the solenoid, but only if this switch is also pressed by the auto sear, meaning the solenoid is all the way back in its resting position. Last bit you'll need to pay attention to is that while it's not obvious here, the final assembly will have the positive positions on the motors swapped, but positive will still run to a negative prong. That's because one of the motors will have to operate in reverse in order for both flywheels to work together and shoot your dart forward. Before we continue, if you bought the kit and don't have a 3D printer, then head over to PCBWay. You can upload the STL files, select options like color, material, infill, and even threaded inserts, although not required for this project. Your prints will begin in just a few days and ship out after a quality check. You can even print in exotic materials like PEEK, although not a financially sound decision for a Nerf blaster. You can also check out their CNC machining, custom PCBs to design your own, more elegant PWM like I'll be adding later. Use my link in the description below for $5 off your first order. I did all my printing on the Snapmaker U1 with a cryo grip plate because I had almost no waste printing PETG with PLA support material, resulting in clean support breakoffs. I also printed with 100% infill to make it more durable and drop resistant. I didn't know what parts were required, so I printed it all and ended up not using the stock and non-solenoid trigger parts, but that's okay. I also elected to use the full dart magazine as I have those already for other Nerf guns, and the longer barrel for some additional accuracy, although I'm not sure it even mattered with darts. I also came back later and extended the bottom part of the trigger because mine wasn't touching the switch, but with another 2 millimeters of length, it worked great. Finally, you must print the barrel tip in orange. Pretty sure in the US that's by law to signify this is not a real firearm. The kit I bought from Frontline Foam has everything included except the 3D printed parts. It even had a few extra parts, like screws, which I hope they're supposed to be extra. Although I'm sure you can source parts from like AliExpress for even less. First time I do any project, I'll pay extra for a complete kit to remove that set of variables for my first build. We're just following the directions, which honestly are still confusing, like they never got peer reviewed. For example, it's all black wires despite being provided with red wires and showing red in the diagram. Pay extra attention to the auto sear, and when you're happy with the runs, I glued my wires to the back of the grip to keep them out of the way. For the switch that triggers the motors, make sure the soldering is done out of the auto sear path, since I had to revisit and solder it on the other side. Finally, I added some super glue to the studs in the switches to keep everything from moving. As long as your auto sear moves freely back and forth when closed up, then you're done with the hardest part. And even the instructions say to return to the other document to continue the rest of the blaster. Oh, shit. This thing shot way too fast. As fun as that was, it'll only bring tears, and Nerf wars are something I want to do often. I tried an 8-volt 2S battery instead of the 12-volt 3S battery in it, and while the motors did spin slower, the solenoid requires 12 volts and did not do anything. Even when pushing the dart through, it was still too fast. I hate to say it, but the Google AI results came in clutch here, and it was even making a mistake. Its last suggestion was a PWM. Despite the source not mentioning PWM anywhere, it was exactly what I needed. A PWM is pulse width modulation and averages the power to a vise by changing the rate it switches from full power and no power. A standard volume knob is a PWM, and so are the fans in your PC when controlling RPM, just like the RPM we need to control in our Nerf blaster. But where? The side is an excellent spot, but our solenoid is wired to the motor and can't use less than 12 volts. Since the battery side of the PWM is 12 volts and the other side is variable, we can move the solenoid ground from the motor to the input side of the PWM so it completes the 12 volt circuit. Let's finish the wiring. I should have jumped the underside that changes the input from 5 to 25 volt to 3 to 13 volt, but oh well, because we've already hot glued it to the side of the blaster. As we'll see in a second, this is much better and should result in far less tears.